Okay, Assalamualaikum and selamat sejahtera to all of you. Right, so today kita akan continue our topic for chemistry for matriculation. Okay, chapter 6 chemical equilibrium tutorial part 1. Right, so which is presented by me, Sir Zul. Okay, alright. So this is the question for chapter 6 tutorial. Okay, number 1, define the following terms. Okay, so berikan definition untuk term-term berikut. The first term ialah reversible reaction. Okay. The second term is law of mass action ataupun equilibrium law. And then number 3 is homogeneous equilibrium, and number 4 is heterogeneous equilibrium. Okay, and then question 1b is state two characteristics of a dynamic equilibrium reaction. Okay, so kita tengok apa jawapan dia. Okay, number 1, reversible reaction is a chemical reaction that can be proceed in both forward and reverse reaction. Okay, reverse direction. Jadi dia boleh pergi ke arah forward or reverse. Okay, number 2, law of mass action ataupun equilibrium law. So it is given by for any equilibrium at given temperature, the multiplication for concentration of products each raised to a power is equal to its coefficient equation divided by the multiplication of the concentration of reactants each raised to a power equal to its coefficient in the equation, and it is a constant. Okay, so ini yang kita selalu tulis KC ataupun KP tu. That is mass law of mass action. Okay, alright. And then number 3, homogeneous. Okay, homogeneous is a reaction in which all reacting species are in the same phase. Okay, berada di dalam fasa yang sama. Alright, so the last one, hetero. Okay, so heterogeneous equilibrium, okay, is a reaction in which all reacting species are in more than one phase. Jadi dia berada di dalam lebih daripada satu fasa. Okay, alright, so next kita pergi kepada soalan 1b. Two characteristics of a dynamic equilibrium reaction. Okay, ciri-ciri keseimbangan dinamik. Okay, so ciri-ciri keseimbangan dinamik, the first one, dia mesti berada di dalam, okay, chemical equilibrium can be established only in a closed system. Okay, so dia mesti surrounding dia ataupun sistem mesti berada di dalam keadaan yang tertutup, sistem yang tertutup. Then number 2, the rate of forward reaction equal to rate of reverse reaction. Jadi kadar masuk sama dengan kadar keluar ataupun kadar ke hadapan, okay, sama dengan kadar ke belakang. Alright, so we proceed to the next question, question number 2. For a reversible reaction below, sketch a graph of the variation of the concentration of A and B with time until the system has achieved equilibrium. Explain the shape of your graph. Okay, so dia suruh kita sketch the graph. Jadi bila kita nak sketch the graph, the first thing yang kita mesti lukis ialah apa? We must draw axis. Okay, y-axis and x-axis. So y-axis is for concentration, manakala x ialah untuk time, masa. And then the reactant kita di sini adalah A. Okay, jadi kalau A is a reactant, initially A will start from a higher state, keadaan yang lebih tinggi. So this kita draw satu curve yang turun ke bawah untuk reactant. Kenapa kita draw turun ke bawah? Because the concentration of reactant is decreasing. And then for B, okay, concentration B will increase. Kenapa B increase? Because B is a product. Okay, so the concentration of B will increase, concentration of A will decrease. Okay, after one time, iaitu time equal to 1, T1, okay, so dia akan berlaku keadaan yang constant. Okay, tiada perubahan. So this one K is not equal to Q, not equal to K. Right, so kita explain the shape for our graph. So concentration A is decreased with time, Kenapa concentration A decrease with time? Because A is reactant. Jadi reactant dia habis digunakan. That's why dia akan berkurangan. Okay. A will decrease, manakala B akan increase. Kenapa B increase? Because B is product. So product akan semakin bertambah. Okay, after time T1, jadi concentration A dan B remain constant. Dia tidak akan ada perubahan lagi di sini. So as reaction proceeds, the rate of forward reaction decreases, the rate of reverse reaction increases. Okay, kalau dia proceed lagi, jadi forward reaction dia akan berkurangan dan reverse reaction akan bertambah. Jadi this is occur when when the rate of forward and reverse reaction become equal. Okay, bila forward dan reverse telah sama, maksudnya dia telah seimbang, concentration A and B remains constant. Okay, tidak akan berubah lagi. Okay, so that's for question number 2. Okay, kita pergi kepada question number 3. Determine whether the following reactions are homogeneous or heterogeneous. So kita dah tengok tadi apa maksud homogeneous. Homo means sama. Okay, jadi kalau untuk the process reaction A, number 1, all in gas phase, they are homogeneous. Okay, this one solid, gas, heterogeneous. This one is aqueous, solid, aqueous. Heterogeneous, solid, liquid, solid, gas. Heterogeneous. Okay, so next question 3B. Write the equilibrium law for the above reaction in terms of concentration Kc and Kp. Okay, untuk tindak balas yang di atas. Jadi first kita ada okay 1. Okay, so untuk 1, okay, for 1 Kc is equal to concentration of PoCl3 square over concentration PCl3 square times concentration oxygen Kc. Untuk Kp dia ada gas, dia adalah gas, jadi kita akan ada Kp is equal to partial pressure of PoCl3 square over partial pressure PCl3 square times partial pressure of oxygen. Okay, so that's for question 1. For question 2, okay, Kc kita just tengok solid, gas. Okay, so untuk solid kita exclude. Okay, kita exclude di sini, just masuk untuk gas. So Kc is equal to concentration of CO2 over concentration of CO. Right, while for Kp is partial pressure of carbon dioxide over partial pressure of carbon monoxide. Okay, next one is Ag aqueous, Fe aqueous, Ag solid, Fe aqueous. So solid kita tidak ambil kira di sini. Okay, exclude. Jadi untuk Kc, okay, our product is Fe concentration Fe3 plus over concentration Ag plus times concentration Fe2 plus. While for Kp, okay, Kp only for gas. So this one is aqueous, this one is aqueous, this one is aqueous. So Kp kita tidak perlu tulis ataupun nilainya adalah 1. Okay, alright. So the last one is for, actually this one tak perlu tulis lah. Okay, alright. So last one Kc. Okay, Kc for question 4. Kc is concentration of hydrogen. Okay, power of 4 over concentration of, so this one is solid. So tiada lah. Okay, right. And for Kp, partial pressure of hydrogen, power of 4. Okay, so that's all for question number 3. Okay, so next kita proceed kepada question number 4. Okay, we have SO2. Okay, SO2 and O2 produce SO3. KM mo yan. Diam. Okay, so right, so the equation yang kita ada di sini adalah SO2 plus O2 produce 2 SO3. Right, so kita tulis dahulu the expression untuk this question. Okay, write the expression. So Kc is equal to concentration SO3 square over concentration SO2 square times concentration of oxygen. Alright, so dekat sini dalam question dia bagi kita mole lah. So this one is mole, yang ini mole, this one also mole. Sedangkan bila kita nak buat concentration, kita kena convert mole pergi concentration. Jadi first of all kita kena convert lah, okay, tukar, okay, concentration of SO3, okay, kita tukar pergi mole. So kita ada 8.7 mole over 12 liter. Okay, right, so we got 0.725 molar. Okay, and then concentration of SO2 1.35 exponent negative 5 moles over 12 liter. Okay, so we got sorry, this one is O2. This one is O2. Okay, concentration of O2 1.35 exponent negative 5, 1.12 exponent negative 6 molar. And then concentration of SO2 2.5 moles over 12 liter. So we got 0.208 molar. Okay, dah dapat concentration, bolehlah kita kira apa? Kc. Okay, so Kc just substitute. Kc is equal to SO3 is 0.725 square over 0.208 square times oxygen 1.12 exponent negative 6. Okay, so the answer is 1.077 exponent 7. Unit tidak perlu letak, okay, untuk Kc. Right, so that's for question number 4. Okay, next kita proceed to the next question. Question 5. The partial pressure of PCl3, O2 and POCl3 at equilibrium are 0.0498, 0.0247 and 0.9967 atm respectively. Calculate the equilibrium constant Kp for this reaction. So kita ada partial pressure for each gas, and then so to find Kp. So it's very simple question. Okay, terus tukar, masukkan saja. Jadi yang ni kita tak perlu tukar je lagi, memang dah dalam pressure. Okay, write the expression first. Kp is equal to partial pressure POCl3 square over this one is partial pressure. Okay, PCl3 square times partial pressure oxygen. So just substitute all the value. Okay, gantikan saja nilai 0.9967 square over 0.0 0.0498 square times 0.0247. Okay, so tekan calculator, dapatlah jawapan dia. Okay, 1.622 exponent 4. Again, tiada unit. Okay. Alright, so that's for question number 6. Next, kita tengok question number, that's for question number 5. Next, we proceed to question number 6. The following reaction achieve equilibrium when partial pressure of bromine gas is 0.6 atm. So, we have bromine gas only. Kenapa bromine gas? Kerana, okay, FeBr3 di sini adalah solid, FeBr2 is also solid. Jadi dia tak masuk dekat dalam expression. Jadi Kp kita is equal to partial pressure Br2 power of half. Dia masukkan saja nilai 0.6 power of half. So we got 0.775. Unit tiada. Okay, tidak perlu unit. Okay, next kita derive. To derive Kp is equal to Kc RT power of half. Okay, so derivation. Okay, question B. So first kita tulis dahulu Kp. Okay, Kp sama dengan partial pressure Br2 power of half. And this is equation 1. Okay, Kc is equal to concentration Br2 power of half. This is for equation 2. So kita assume, okay, assume the gas behave ideally. Okay, so partial pressure for bromine equal to N bromine RT over V. Okay, which is equal to partial pressure bromine equal to concentration bromine RT. Okay, so this is equation number 3. Okay, right, so kita equation 1, equation 2, equation 3. Okay, so now kita ambil partial pressure of bromine di sini, which is equal to concentration of bromine RT. Kita masukkan dekat dalam equation 1. Okay, so substitute equation 3. Okay, equation 3 into equation 1. So after we substitute 3 into 1, equation kita akan jadi, okay, Kp is equal to, so Br2 sama dengan concentration, okay, PBr2 concentration RT power of half. Okay, and then, okay, kita darab keluar, dia akan jadi Kp is equal to concentration Br2 power of half RT power of half. Alright, where this is equation number 4. Okay, this is equation number 4. We substitute equation 2 into equation 4. Okay, substitute 2 into 4. Jadi 2 tadi, Br2 power of half equal to Kc. So kita substitute Kp is equal to Kc RT power of half. Alright, so derive. Okay, so this is the derivation untuk question number 6. Okay. Alright, so next, at 25 degrees Celsius, okay, water reach equilibrium according to the equation H2O produce H2O, liquid produce gas. Calculate Kp and Kc for this reaction. So you are given vapor pressure of water at 25 degrees Celsius is 23.8 torr. So first of all, dia bagi vapor pressure ni di dalam unit apa ni? Torr. So you kena convert pergi ATM. Kenapa kita perlu convert pergi ATM? Because relation di antara KP, KC, RT, delta N di sini, okay, our temperature it will be in Kelvin and R is in liter ATM per mole per Kelvin. That's why kita tidak boleh pakai unit torr untuk calculate KP. Okay, kalau dia minta KP saja, tak ada masalah, kita terus bagi dalam unit torr. Okay, alright, so KP, okay. First of all, kita tukar dulu lah pressure. So pressure sama dengan 23.8 torr. So 23.8 torr equal to, okay, 23.8 torr over 760 torr times 1 ATM. Where 1 ATM sama dengan 760 torr. Okay, right, so kita cancel the unit torr later. Kita akan dapatlah pressure in ATM which is equal to 0.0313 ATM. 313 ATM. Okay, so kita dah ada unit in pressure in ATM. So automatic our KP kita boleh tulis lah. Okay, 0.0313. Okay, sorry, this one tidak perlu unit tidak perlu unit. Okay, because our KP, okay, KP is equal to partial pressure H2O. Jadi partial pressure H2O kita dah dalam 0.0313 ATM. So this is our KP. So KP is equal to KC RT delta N. So delta N is equal to gas 1 minus 0. Okay, so delta N is equal to 1. Temperature is 25 degrees Celsius. Temperature convert to Kelvin is equal to 298.15 Kelvin. Okay, 25 plus 273.15. So dapat 298.15 Kelvin. So just substitute the value. Okay, mula kita rearrange the equation. KC is equal to KP over RT delta N. Dan gantikanlah nilai. So our KP just now is 0.0313. Our R is 0.08206. The temperature is 298.15 Kelvin. Delta N is 1. Okay, so tekan calculator, dapatlah final answer which is 1.28 exponent negative 3. Okay, so that's for question number 7. Okay, so now let's continue to question number 8. Okay, right, so you are given 1 mole each of carbon monoxide CO and Cl2, okay, which is introduced into an evacuated 1.75 liter flask at 668 Kelvin. At equilibrium, the total pressure of gaseous mixture is 32.4 atm. Calculate Kp. So the final answer given is 25.9. Okay, so maksudnya di sini we need to calculate the partial pressure for each gas initial for CO dan juga Cl2, because initially you are only given number of mole and volume and also the temperature. Okay, so first kita kira dahulu pressure initial of each gas, okay, untuk carbon monoxide dan juga chlorine gas. Jadi to find the pressure, calculate the pressure kita gunakan PV is equal to nRT. Okay, PV is equal to nRT. Initial, okay, pressure initial is 31.32 atm. Okay, so inilah value yang akan kita gunakan di dalam, okay, our ice table. Okay, di dalam ice table kita we have pressure initial, pressure change, pressure at equilibrium. So initial pressure just now kita dah kira 31.32. Okay, so this one also 31.32. Okay, and then COCl2 0. So the change is, okay, kalau kita tengok dekat sini semua perkali dia is 1. So kita minus x plus x. So at equilibrium is 31.32 minus x, 31.32 minus x, x. Okay, so P total, okay, soalan di sini dia bagi the total pressure of the gases mixture is 32.4 atm. So P total at equilibrium, P total sama dengan, okay, so kita tambah semua ni, P carbon monoxide, P chlorine, P CO, Cl2. Jadi 31.32 minus x plus 31.32 minus x plus x, which is equal to 32.4. Okay, so solve for this. Okay, selesaikan untuk x. So you akan dapat x is equal to 30.24. Jadi kita dah dapat x is equal to 30.24 atm. Okay, sorry, 30.24. So kita gantikan lagi ke dalam ini. 31.32 minus x. Okay, so untuk PCO, okay, kira satu-satu. PCO is 31.32 minus x, which is equal to, so chlorine pun sama, jadi kita kira sekali je. 31.32 minus x, 31.32 minus 30.24. Okay, so we got 1.08 atm. Press each one untuk chlorine dan juga CO. Okay, so X ini adalah untuk siapa? CO, Cl2. So Kp, formula Kp equal to partial pressure CO, Cl2 over partial pressure CO times partial pressure Cl2. So substitute all the value here. Okay, gantikan semua nilai yang kita sudah dapat tadi, iaitu COCl2, okay, is x, which is x is equal to 30.24 over 1.08 square. Okay, because the pressure is the same for CO dan juga Cl2. So final answer is 25.9. Okay, dimensionless. Unit not required. Okay, so that's for question number 8. Okay, alright. So next, okay, question number 9. Okay, for question number 9, you are given ammonium hydrogen sulfide decomposes at 250 degrees Celsius. According to the reaction, NH4HS solid produce NH3 gas plus H2S gas. Kp given is 0.110. Okay, if 55.0 grams of solid NH4HS is placed in a sealed 5 liter container, what is the partial pressure of NH3 and H2S at equilibrium? Alright, although you are given the mass, okay, the mass, actually mass yang dia bagi ni, okay, kita cuba tengok kita cuba tulis dia punya ice table. Okay, NH4HS solid produce NH3 gas plus H2S gas. Okay, so the pressure initial is, okay, so pressure initial, so nampak tak di sini? Okay, look at this. This one is in solid. So solid, kita terus letak apa? Dash. Okay, solid tak perlu masuk dalam ni. So initially, okay, H2S dan ammonia is 0. Hydrogen sulfide and ammonia, gas initial is 0. Kenapa 0? Because initially tiada lagi gas di dalam system. Okay, alright. So the change is, this one is kita positive x, okay, plus x. So 0 plus x is equal to x, x. So Kp is equal to, okay, partial pressure NH3 times partial pressure H2S, which is equal to x times x or x square. So Kp given is 0.11. So 0.11 equal to x square. Boleh tak kita cari x? Boleh. Okay, x is equal to square root 0.11. Okay, so kita dapat x is equal to 0.33 atm. So this is partial pressure of ammonia, okay, equal to partial pressure of H2S, which is equal to 0.33 atm. Okay, alright, so that's for question number 9. Okay, next kita pergi kepada soalan number 10. Question number 10. So for question number 10, you are given bromine gas is allowed to reach equilibrium at 1280 according to the equation. Okay, Br2 gas produce 2 Br gas and Kc is 1.1 exponent negative 3. If the initial concentration of bromine and bromine gas and bromine atom are 0.063 molar and 0.012 molar respectively, calculate the concentrations of this species at equilibrium. So you are given the Kc now. Okay, so this one kita kena cari nilai X. Okay, kita buat Ice table, kemudian kita cari nilai Kc. Okay, so kita bukan cari nilai Kc, we find the value of X, okay, because we have the value of Kc. So kita tulis dahulu dia punya equation to produce the ice table. Br2 gas produce 2 Br gas. So initial concentration, okay, di dalam molar is initially is 0.063 molar, 0.012 molar. So the change in concentration molar is minus X, this one is plus 2X. Okay, concentration at equilibrium is 0.063 minus X, this one is 2X. Okay, at equilibrium. Oh sorry, this one is 0.012 plus 2X. 0.012 plus 2X. Okay, so Kc, okay, Kc given is 1.1 exponential negative 3, which is equal to, okay, which is equal to Br, concentration of Br square over concentration of Br2. This one is based on this equation berdasarkan equation di atas, which is bromine kita ada 2 Br and Br2 gas. Okay, so now okay, substitute nilai yang kita sudah dapat di dalam ice table tadi. Okay, kita solve untuk siapa? Solve for X. Okay, so Kc is equal to 1.1 exponent negative 3. So 1.1 exponent negative 3 equal to, so Br square. Okay, so Br is 0.012 plus 2X. So this one is 0.012 plus 2X square over Br2 is 0.063 minus X. Okay, and then kita akan expand the equation, form quadratic expression. Okay, so darabkan quadratic expression. Okay, so darabkan, darab panjang semua, expand the equation. Okay, so akan jadi 4x square plus 0.049x plus 7.47 exponent negative 5 equal to 0. Okay, so kita dah ada quadratic expression yang ada value apa di sini. This is our A, this is our B, and then this is C. Kemudian tekan calculator, masukkan di dalam calculator. So you akan dapat X1, okay, X1 is negative 1.78, exponent negative 3, X2 negative 0.01050. Okay, so di antara dua nilai di sini, okay, kita tengok yang mana kita sesuai untuk kita masukkan ke dalam expression di atas. Okay, right. Obviously, okay, kalau kita letak nilai ini, kita ambil X2, gantikan ke dalam expression BR, okay, di mana untuk concentration BR, okay, BR2 equal to 0.063 minus X, concentration BR equal to 0.012 plus 2X. Jadi, bila kita masukkan dalam expression ini, 0.063 minus X, okay, X, katalah kita ambil X2, okay, bila kita ambilkan X2, this one tiada masalah, okay, tapi bila kita masukkan dekat sini, dia akan jadi negatif. So, X2 will be neglect, okay, so kita akan neglect X2. X2 ni kita tidak ambil, okay, so we choose X1. So, when we take X1, okay, substitute the value for X1, kita akan dapat the concentration of bromine 0.0084, okay, 0.0084 molar, and concentration of Br2 0.065 molar. Alright, so this is the final answer. Okay, kita nak cari apa? Concentration of the species at equilibrium. Okay, so that's for question number 10.